For this example, we need to state the domain of the function. We have f of x is equal to two fractions being added together. The domain is always going to be all real numbers except whatever would cause you to get an error in the problem and not be able to calculate a y value. With this problem, we have some division, and you do get an error when you divide by 0. So basically, we just need to ask ourselves, what would we plug into x here that would cause us to divide by 0? And if we plug in 3 for x, we're going to have 7 over 3 minus 3, which would be 7 over 0, and that would give us an error. So if you plug in 3, you can't calculate a y value. You would get an error. So therefore, 3 is not part of the domain. So the domain can be written a couple of different ways, but you can always start this way. It's going to be all real numbers except. For these problems, that's a decent way to do this because we're just going to be excluding individual numbers. All real numbers except x cannot equal 3. And then for this denominator, if we plug in a -5, we would also get an error because we would be dividing by 0. So it's all real numbers except x can't be 3 or -5. The all real numbers except piece is kind of implied. You really don't even need that. If you say x is not equal to 3 or -5, that implies that everything else is okay. So to state your domain on this, you can just look at the equation, and if the denominators are easy to work with, you can just say x is not equal to whatever would cause you to get it a 0 on the bottom of that fraction. For letter B, we're going to take a look at x plus 6 over x squared plus 5x plus 6. Well, again, we just have a single fraction this time, but whatever I would plug in here and get 0, that is what I would need to eliminate from my list. So it's going to be all real numbers except whatever would give me a 0 on the bottom of the fraction. This is a little harder to see if you can't just do it by inspection like we did in letter A, where it was very obvious what those values are. What you can do is just take your denominator and set that equal to 0, and then solve. And that will tell you what would give you a 0 on the bottom. So if I take a look at this left side, I have a couple of different options. Factoring is probably going to be the fastest method, but you could use the quadratic formula and a few other methods as well. But let me just go through and factor this. I have our polynomial on the left, 0 on the right. I'm ready to factor. There's nothing in common with those three terms. I have a trinomial, so I'm looking for two numbers that add to be 5 and multiply to be the invisible 1 in front of the x squared times the 6, which is 6. So adds to be 5, multiplies to be 6. Those two numbers are 2 and 3. So for this problem, we're looking for two numbers that add to be 5 and multiply to be 6. And those two numbers are 2 and 3. Because we have a 1 in front of our x squared, I could use the shortcut to factor, and I do end up with an x plus 2 times an x plus 3 when it's in factored form. Now we have two things multiplied together that equals 0. Using the zero product property, I can set each one of those things equal to 0 and come up with two easy equations to go through and solve. So if you plug in a -2 in for the x's, you're going to get a 0 on the bottom, and that will give you an error. So -2 is not part of the domain, and neither is -3. So your final answer is all real numbers except -2 and 3. I'm sorry, -2 and -3. But the easiest way to make a statement about that is just to say that x cannot be -2 or -3. So these problems you can go through and do with inspection if the denominators are really easy. If the denominator is a little more complicated, you'll need to set it equal to 0 and then solve, and then you can make a statement about the domain.